Stoichiometry. Funny word, but stoichiometry is the study of the amount of reactants and products in a chemical reaction. If we know the amount of one of the chemicals in the reaction, we can calculate the amount of the other. And this is because we've got a balanced chemical equation, and that gives you the ratio of moles reacting. Now, we've already done a lot of this with our acids and bases, and you've done it without really thinking about it. So here's our balanced chemical equation. We've got iron sulfate plus 2 sodium hydroxide make iron hydroxide plus sodium sulfate. If we have a look at this equation, you can see that when there's no number in front, it's saying that 1 mole of iron sulfate reacts with 2 mole of sodium hydroxide to make 1 mole of iron hydroxide and 1 mole of sodium sulfate. And that's all I've got written down here. 1 mole of iron sulfate reacts with 2 moles of sodium hydroxide to produce 1 mole of iron hydroxide and 1 mole of sodium sulfate. If then we only have half a mole of iron sulfate, it will react with 1 mole of sodium hydroxide. Why? Because 1 mole reacts with 2 moles. Thus, half a mole will react with 1 mole. It's just a mole ratio. And that will produce half a mole of iron hydroxide and half a mole of sodium sulfate. Okay, so the first step you need to do whenever you're given a question is write a balanced chemical equation. So identify from that balanced chemical equation and from the information that you're given the known and the unknown. So what you know, what quantities you've been given, and what you're trying to work out. That's probably one of the hardest parts of the question, is establishing what it's asking. The second thing you want to do is calculate the number of moles of the known. So the number of moles of the known substance. That can be given to you in grams or in volume and concentration. You need to convert that to moles. The third thing is to use the equation to find the mole ratio. So that's meaning the proportion of known to unknown quantities. From that, you're able to calculate the number of moles of the unknown. So we've gone from the number of moles, we've used the mole ratio, and we can work out the number of moles of the unknown. And then last but not least, we convert it into what the question's asking for. If you know the number of moles, you can always convert it to mass or volume if you know the concentration. I know it probably sounds a little bit confusing, but I'm going to work you through a couple of examples. You've already done a little bit of this with acids and bases. So here we go, just step by step again. Step 1, write a balanced chemical equation. Step 2, the amount of known in moles. Third step, work out your mole ratio. And your mole ratio is always the moles of the unknown divided by moles of the known. There's a couple of ways you can do this calculation. If you're good at maths, you can do ratios, which is the way that I work it. But if you're a little bit unsure, remember that mole ratio is the moles of the unknown divided by the moles of the known. Fourth step here is the amount of unknown moles. So work out that from your mole ratio. And then the last step here is to find out the amount of unknown, which can either be weight or volume. But let's have a look at some examples. So this is mass to mass stoichiometry. We know the mass of one substance and we're going to work out the mass of another substance. So the first step is to work out the mass of the known that you'll be given, change that into moles. Once you've got the moles of that, you use your mole ratio relationship. You can work out the number of moles of the unknown. Once you've got the number of moles, you can work out the mass. Okay, so here's an example question. When a piece of zinc is placed in a silver nitrate solution, it slowly corrodes and crystals of silver grow on its surface. If 5 grams of zinc is added to excess silver nitrate solution, that just means an awful lot of silver nitrate, that there's enough to react completely with that 5 grams. You'll see this word a lot and it'll make a little bit more sense in a couple of lessons. So it's added to excess silver nitrate solution and eventually totally dissolves. What mass of silver crystals will be produced? So let's have a look at the information that's given to us. We're told that the first thing is you need to write the chemical equation. This has been given to you here. So we've got zinc sulfate piece of zinc is placed in silver nitrate solution, so we've got silver nitrate solution. It slowly corrodes and crystals of zinc grow on the surface. So we're getting solid silver forming, which is written here. And we need to look at what's going to be left and what's going to be left from this reaction. So if silver's forming, it's an ionic equation or an ionic reaction, so zinc will match up with the nitrate to form zinc nitrate. Balance that equation, need to have a 2 in front of the silver nitrate because you've got 2 nitrates here, and you'll also need to put a 2 then in front of the silver. So we've got the balanced chemical equation. So if 5 grams of zinc, so 5 grams of zinc, that's what we know, and we're wanting to find out what mass of silver crystals will be produced. So what mass of this is going to be produced? So the information we have is that the mass of zinc is 5 grams, and we always know big M, which is 65.4. Where do we get that from? Periodic table. And here we have the molar mass of silver, which is 107.9, and we need to work out the mass of silver. Now I can't advise you more strongly, set things out nice and clearly like this. If you set things out like this, the first thing is you can follow what you're doing and you'll get into a very good step-by-step process. The second thing is an examiner can follow what you're doing. The more information you have, the more marks you will get. Even if you get the question wrong in the end, if the examiner can follow what you did, he or she will give you as many marks as he or she can. Okay, so second step, calculate the amount of the known in moles. So the known is zinc. So N equals M on M, which equals 5 divided by 64.5. So we've got 0.0765 mole. Fabulous. Now we need to look at the mole ratio between the unknown and the known. So remember, the mole ratio is always the number of moles of the unknown divided by the number of moles of the known. So here we have a ratio of 2/1. So 1 mole of zinc will make 2 moles of silver. So therefore, if we multiply by the mole ratio, which is 2 divided by 1, times the number of mole of zinc, we're going to figure out the number of mole of silver. As I said, mathematically you can do those a few ways, and I'm trying to simplify it using this mole ratio. So we'll get the amount of silver equals 0.153. So all I've done is work out the mole ratio, which is 2 divided by 1, which is the unknown divided by the known. The unknown divided by the known. So the 2 divided by 1 times the amount of zinc there, which is multiplied by that, which will give us the amount of silver, which is 0.153 mole. Once we've got the mole, it's easy again to convert that back to the mass of the unknown, which is mass of silver equals the number of mole times the molar mass, which is 0.153 times 107.9, and it equals 1.67 grams. So the first step you need to do is to write a balanced chemical equation. So here we've got magnesium, which is being burnt in oxygen to form solid magnesium oxide. Magnesium, solid, plus oxygen, gas, forms magnesium, which is 2 plus, oxygen 2 minus, O, MgO. And that's a solid because it says so in the question. So we've got 1 magnesium, 2 oxygen, 1 oxygen, so I need to put a 2 here. So that means I need to go back and put a 2 in front of the magnesium. So I've got a 2 to 1 to 2 ratio. Second part of the calculation is to calculate the amount of known or mole in the known. So this is my known here. So I know that M equals 10 grams. Tells me this in the question. Big M, I look on the periodic table and I can see is 24.31 grams per mole. I can now solve for N, which is the number of mole, which equals mass divided by molar mass. 10 divided by 24.31 equals, and the answer to that is 0.411 mole. Now it's time to look at the mole ratio of magnesium to magnesium oxide. And it's a 2:2 ratio, or a 1:1 ratio if you work that out. So 1 mole of magnesium will make 1 mole of magnesium oxide. 2 mole of magnesium will make 2 mole of magnesium oxide. The other way, as this can start getting confusing, is to work out mole ratio equals number of mole of unknown divided by number of mole of known, which in this case is 2 divided by 2, so it's a mole ratio of 1. Now the one thing I should have done at the start of the question is it's always really important when you're reading a question to write down what you're looking for. It will just keep reminding you what you're going back to. So do this at the start of the question, that mass equals question mark. So here's my mole ratio. So step 3, I can calculate the amount of the unknown now using this mole ratio. So if I've got 0.411 mole of magnesium, it's a 1:1 ratio, so I'll have to have 0.411 mole of magnesium oxide. Or if I'm using the mole ratio, I can do that 0 will equal mole ratio times 0.411, which will obviously, since mole ratio is 1, equals 0.411. So now that I know the number of mole of magnesium oxide, number of mole of MgO equals 0.411. I'm trying to find the mass, which I've written up here so I remember. So M of MgO equals N times big M equals 40.3 grams per mole. I'll just put that up the top as well. Big M equals 40.3. So therefore M equals 0.411 times 40.3, which equals 16.6 grams. And that is my final answer. This has 3 significant figures because the question here has 3 significant figures. So the question's asking what mass of lead oxide and what mass of oxygen are produced by the decomposition of 8.4 grams of lead oxide according to the following equation. So the equation's already been given here for you. So that's half the battle won already. We like questions like that. Okay, so what do we know? We know 8.4 grams of lead oxide. So write that down. M equals 8.4 grams of lead oxide. We always know molar mass. So molar mass equals 1 lead, 2 oxygen, so it equals 239.19. Do not multiply the molar mass by the numbers in front. The numbers in front are just relating to mole ratios. Okay, so that's grams per mole. And let's have a look at what we're looking for. We're trying to find out, we want to know the mass of lead oxide and the mass of oxygen. So M equals question mark, M equals question mark. Remember, we always know what big M is, so write those in straight away. So the molar mass of lead oxide is 223.19, and the big M of oxygen is 2 times 16, which will be 32 grams per mole. So this is all the information that we need to work out this question. So we can now work out the number of mole of lead oxide. N equals M, and N equals 8. Which equals 0.03. We need to look at our mole ratios now. We have 2PO2 will react with 2PbO. So 2 of these will produce 2 of these, 1 of these will produce 1 of these. So it's a 1-to-1 ratio. So remember, we can work out mole ratio. Mole ratio equals number of mole of unknown divided by number of mole of known, which equals 2 on 2, which equals 1. So now that we know that we've got 0.035 mole of PbO2, that will produce the mole ratio, which is 1, times the amount here, which is 0.035 mole PbO2. Thus the amount of PbO2 is 1 times, so N of PbO equals 0.035 mole. Now that we know how many mole we have, we know what big M is, so we can work out the mass, which is what we're endeavouring to find out, remember. So the mass equals N times M, which equals 0.035 times the molar mass, 223.19, which equals 7.8 grams. Two significant figures, because we're using two significant figures here. Sorry, beg your pardon, it's three significant figures, because there's 3 here. Remember the 0 is above, so it will be 7.81 grams. So what mass? We're going to try to find out oxygen now. So I'll just convert our information from our other slide. So we've got big M equals 32 grams per mole, and we've already worked out that N equals 0.035 mole. We did that in the previous part of the question. So now it's just a case, we're trying to find out the mass of oxygen. Looking at our mole ratio again, we've got 2 mole of lead oxide will react to give 1 mole of O2. So it's 2 will make 1. So if we work out mole ratio equals number of mole of unknown divided by number of mole of known, which will equal 1 divided by 2. So mole ratio is a half, and that makes sense. 2 lead oxide will produce a half the quantity of oxygen. So we know that we've got 0.035 of lead oxide, which will make a half times 0.035 of O2. We can work out the number of mole of O2 will equal a half times 0.035, which equals 0.175 mole. Now that we know the number of mole, all we have to do is work out the mass. The mass of oxygen equals N times M, which equals 0. Sorry, I forgot a decimal place up here, I apologise. 0.0175 times 32 equals 0.56 grams. So that's our final answer again. Okay, so there's a few questions you can have a go at now. Have a go at the booklet questions while this is fresh in your mind, and then you can start making some work on chapter 15, but we'll work through this in class tomorrow.